So you just got your Math 327 final exam and you're feeling a little overwhelmed. It looks like there's a lot to do, but don't worry, you've got a good 10 days or so to finish this thing. So what I want to do is I want to kind of briefly describe the problems, and then I want to give you a clear sense of what my expectations are in terms of the write-up. The exam consists of 6 problems. In the first problem, I give you some matrix. It's a 5 by 8 matrix, so it's made up of 8 column vectors, each of which is in R5. And I don't give you the matrix, but I give you the row echelon form. And then I ask you various questions about this matrix. And this is very similar to a problem you had on your first exam, as well as an activity, a class activity, I believe, as well. So none of this should look very new to you. Please keep your explanations brief and to the point. In the second problem, I've given you a linear system of equations with a 3 by 3 matrix A and a vector B, and I'm going to ask you to solve this 2 ways. First, I'm going to ask you to solve it using a PLU factorization, where L is a unit lower triangular, U is an upper triangular, and P is a permutation matrix, and then use your factorization along with forward and backward substitution, but no elementary row operations to solve AX equals B. In your final write-up, show all the steps that lead to the constructions of P, L, and U. So don't leave those steps out. You can use technology only for the purposes of checking your final solution, which I encourage you to do. Now, in the second question, you're going to solve the system, but here you're going to use the singular value decomposition. I suggest using technology to compute the matrix factors in the decomposition, approximate them to 2 decimal places, include them in your final write-up, then use matrix multiplication, inversion of diagonal matrices, and properties of orthogonal matrices. No elementary row operations to solve AX equals B. And of course, the solution you get in B should agree with the solution you get in A. Otherwise, a mistake was made. Okay, now we're going to change the matrix A slightly so that we're still going to keep the vector B from above. Now AX equals B is inconsistent. So what I'm asking you to do is I'm asking you to find the least squares solution to AX equals B. In your final write-up, indicate the least squares solution itself, the matrices used in the SVD factorization of A, as well as the magnitude of error, the norm of AX minus B. Approximate all values to at most 2 decimal places, please. Number 3 is an inner product problem, where we define an inner product on Rn by the inner product of x comma y is x transpose AY, where A is some fixed symmetric positive definite matrix. And so I ask you to do some calculations here and some other calculations. And this is not too far removed from what you did on the first exam when you were dealing with a vector space of functions. Question 4. The Star Wars film, The Empire Strikes Back, the strength of association between each pair of characters can be measured by counting the number of times they speak in the same scene. The results are summarized in a weighted symmetric adjacency matrix. There are 21 characters whose names are listed in Table 1. I'll show you that in a second. The matrix info is stored in a CSV file that I will be sending you by email so that you can download it to directly where you did probably the Karate Club problem for exam 2. What I want you to do is I want you to perform spectral clustering, dividing things into 5 clusters, and I indicate what to include specifically in your write-up. And then we have a recommender system dealing with the Department of Mathematics Microbrewery Club, and you're going to construct a recommender system as well. And then finally, we're going to do an image compression problem, looking at a CTA that was done on me a few days ago. So for the Star Wars data, the Star Wars problem, that's the only problem for which you will actually need to download some data. Let me try to get this focused here. Okay, so in the Karate Club example, there were 34 individuals. In this example, there are 21 individuals. Here's the matrix for the Microbrewery Club. You're going to be figuring out estimated rankings for various professors for some missing breweries. in this matrix. And then here's the picture for the last problem. Not that you'll need the picture. I just thought it would be funny to include. We could have a picture of a puppy or something like that. It's not really relevant for solving the problem itself. So let's actually talk about the write-up a bit. This is important. Okay, so make sure you follow guidelines for written assignments. This includes your submission should be single-sided, including computer output, please. Due to the length of the write-up, follow these directions. Your exams are going to be fairly big, and I don't want you to try to find a big monster stapler. It's going to be hard for you. It's only going to make things hard for me, too. So staple separately your responses to each of the 6 questions. Make sure to print your name in the upper top right corner of the problem write-up and the problem number itself in the top left corner. I'll show you an example in a moment. Attach all problems together using a binder clip or similar means. Do not staple all your problems together, though, because I'm going to be separating things into 6 piles. What I suggest you do is you would invest in a binder clip or something like that. Submit your exam using one of these. You can come and get it back at the end of the semester or in the fall or something like that. We paid for your CoCalc subscription, so asking you to buy one of these I don't think is too out of the question. Okay, so the directions indicate what information should be included in the handwritten or typeset write-up. By typeset, I mean LaTeX typeset. And you're going to have some substantial calculations. Your response for each problem should consist of a brief handwritten summary indicating only those quantities that are requested, followed by inclusion of a Jupyter notebook or other supporting documentation, which itself starts on a new page. Refrain from displaying lengthy output in your Jupyter calculations. You may not complete the entire write-up of the exam, nor the write-up of any particular problem in a Jupyter notebook. Okay, guidelines for citing technology are the same as in exam 3, and then here's the due time, 2 p.m. on Wednesday, April 24th. So let me give you an example. This is a write-up of the actual karate club problem from the last exam. It's a student's, one of your write-ups. I've changed things slightly. So if this problem were to appear on the final exam, it's kind of like the Star Wars problem. What we would do is we would put the name in the top right, Jane Doe. We would label problem 2. And in this particular problem, you had 34 individuals, and this student indicated which people belong to each cluster. And this was very easy for me to check. I just looked 5, 6, 7, 11, 17. I looked at these. I knew the remainder were in here. This was very easy for me to check. The directions also indicated to include the upper 4x4 submatrices of L and the matrices that form the symmetric decomposition of L, and the student has done that as well. So they've included the answer that I wanted. They included the matrix quantities that I requested. And then I also asked for the centroids. So the student included the centroids as well. And on the exam, the final exam, I asked you to approximate things only to a couple decimal places. They went to 3 places. That's perfectly fine. Now, immediately following the question, not at the end of the exam, you should include supporting Jupyter notebooks or documentation, and don't put a whole bunch of stuff in here that doesn't need to be in here. Some of you are using templates from the beginning of the semester which are embellished with text. Please remove that. This student has included the basic functions. The student also printed out the adjacency matrix. That's not necessary. Let's only print out in our Jupyter notebook what's really relevant. This student included the first top 5x5 submatrix of the Laplacian and a few other quantities. The student did not print out the large 34 by 34 diagonal matrix because that just takes up a lot of space and I didn't want it. The student did actually print out the indices corresponding to the 3 smallest eigenvalues which are needed. So in general, I won't be looking at the technology output unless there's a mistake in the answer. So on exam 3, a common mistake was for people not to figure out that the indices, that the 8th, 10th, and 14th eigenvalues corresponded were the smallest eigenvalues, which is why we picked off columns, only these 3 columns from the matrix Q that made up the symmetric diagonalization. So what I showed you here together with this Jupyter output would be stapled together as one problem, making sure at the top of the problem to indicate the number of the problem and your name as well. And then you submit all the problems in order. The cover sheet should be signed, and use a binder clip to put everything together. Thanks. I'll get these things graded for you quickly.